interest to intermolecular forces such as the covalent bonds that hold atoms together in molecules and polyatomic ions. Intermolecular forces hold molecules together in a liquid or solid state. Intermolecular forces are generally much weaker than covalent bonds. There are two types of intermolecular forces, hydrogen bond and van der Waals forces. Van der Waals forces can be divided into two, dipole-to-dipole forces and London dispersion forces. Hydrogen bond is an attractive force between hydrogen that is covalently bonded with nitrogen, oxygen, or fluorine of one molecule with nitrogen, oxygen, or fluorine in another molecule. Hydrogen bond exists between molecules that have hydrogen atoms bonded to either nitrogen, oxygen, or fluorine atoms. Because of nitrogen, oxygen, and fluorine are very electronegative atoms, thus molecules that have hydrogen atoms bonded to either nitrogen, oxygen, or fluorine atoms are highly polar. Very strong dipole-to-dipole forces exist between the molecules. London dispersion forces exist between nonpolar molecules. In a nonpolar molecule, the electrons' distribution around each nucleus is almost symmetrical and electrons move randomly. There is a possibility that at an instant moment there are more electrons closer to one of the atoms. The dipole moment is called instantaneous dipole or temporary dipole because it lasts for a tiny fraction of a second. The instantaneous dipole induces a dipole in each of its nearest neighbor. The electrostatic forces between the instantaneous partial positive charge pole of a molecule and instantaneous partial negative charge pole of adjacent molecules produce London dispersion forces. These dipole moments are not consistent and exist temporarily, yet they still contribute to the attraction between the molecule. The strength of London dispersion forces depends on the size of the molecules. Bigger molecules will have stronger London dispersion forces. Dipole-to-dipole forces exist between polar molecules. The electrostatic forces between the permanent partial positive charge pole of a molecule and permanent partial negative charge pole of adjacent molecules produce dipole-to-dipole forces. Molecules with higher polarity, stronger dipole-to-dipole forces. Intermolecular forces determine the melting points of solids and the boiling points of liquids. Liquids boil when the molecules have enough thermal energy to overcome the intermolecular attractive forces that hold them together, thereby forming bubbles of vapor within the liquid. Similarly, solids melt when the molecules acquire enough thermal energy to overcome the intermolecular forces that lock them into place in the solid.